Hello students, welcome to Spectra Education Academy. In this video, I am going to discuss about position vector first. So first, what is position vector? Position vector. So the definition is the vector which specifies the position of a point with respect to some fixed point. So this fixed point, you can call it as like origin. So suppose, for example, let us say if there is a point P, so at this point there might be even particle. So the coordinates are x comma y comma z. So position of the point from x-axis, y-axis and z-axis like this. There is a point in with respect to origin. With respect to origin, O is. So just you try to understand with the help of diagram like this. Suppose let us say this is just like imagine there is just like a room. There is a point you take in room in the space. So that point is nowhere in contact with the x-axis or y-axis or z-axis, but is in air. So this is the point, you understand. This point P you take in the space, in the air only, within the room, in the air. Now you can understand that suppose this is the origin, it is a point P, it is in connection with x-axis, it is in connection with y-axis, even it is in connection with z-axis also, like say which comes towards us. The walls which are not appearing here, so this is one wall A, B, C, D, but it is very much there. Even you can say E, F, G, O. So these are the walls which we are not able to see, but they are very much present. So that will be z-axis, you call it as. So from P2 towards the wall ADBC is z-axis. Now what are the coordinates here of point P, x, y, z? Now keeping this in mind, you can just draw like this. This is y-axis, this is x-axis, this is z-axis. So z-axis means which is coming towards us. So point P is here. So it is very much connected with x, y is z-axis. Say like this. So this is the position vector. So it is a point P, x, y is z. No. So how to represent it? So you call it as this is vector A having a length of OP. Now the position vector is OP. You can also call it as A. This is the position vector. So it is xi cap. So x is the magnitude and I is the corresponding unit vector. Yj cap. So this is the magnitude along y-axis and corresponding unit vector. Zk cap. So z is the magnitude and corresponding unit vector, that is k cap. So even you can also take its magnitude of position vector. Magnitude of position vector is, you can write like this, OP dash, or you can also write A bar mod. So this is going to be x square plus y square plus z square. So here there is one more point. If the two vectors are acting at an angle 90 degrees, so they are called as orthogonal vectors. Orthogonal vectors. Now let us move to addition of vectors. Addition and subtraction. First let me move to addition of vectors. So you can write like this. If two vectors are represented by magnitude and direction, by the sides of a triangle, then the third vector will be the, or you can say third side, then the third side taken in the reverse order. Represents their resultant. So this is one of the way to understand addition. So you can understand with the help of diagram like this. So this is vector A. So this is vector B. This is A. Now you can take like this. Otherwise you can draw like this. So this is going to be A plus B, addition. This is one way of adding vectors. The second is, if three vectors are simultaneously acting at a point, have zero resultant, then these three vectors can be represented by magnitude and direction, by the three sides of triangle taken in order. So now, so this is going to be like this. So this is vector A. So this is vector B. This is vector A. Now this is going to be vector C. So finally what you can write is A plus B plus C is equal to 0. So there are laws here for vector addition. So first is it is commutative. So it means A plus B is equal to B plus A. So second is it is associative. It is associated. It means A plus B plus C like this is equal to, you can write A plus B inside the brackets plus C. Now moving to vector subtraction. So subtraction of one vector from the other is the addition of a negative vector. Addition of a negative vector addition of the negative vector of the first vector to the second vector. So you can understand with the help of a diagram like this. Say this is first vector, otherwise you can take like this. So this is the first vector, say this is A. So this is the second vector, so this is B. Suppose if you join these two, so therefore this is going to be A minus B. So this is minus B. So you can say A plus of minus B is equal to A minus B. So this is an example for subtraction of one vector and the other vector. So laws are vector subtraction. Cannot obey both associative, first commutative and associative law. So it means A minus B cannot be written as B minus A. This first one. Second one is A minus of B minus C is not equal to A minus of B minus C. Students, in my next video, I'll continue with the rectangular components of a vector. It means whenever a vector is falling in the plane x and y, making an angle theta with x-axis or 90 minus theta with y-axis, it will get the two components, and thereafter I'll continue with the cosine angles. After that, I'll continue with parallelogram law of vector addition. Thank you very much for watching my video, but don't forget to share and subscribe with your friends and relatives. Please make your comments.